All right, we're going to start out Unit 6 covering basic parallelograms. You guys have seen parallelograms before. We're just going to go into more depth than you have in the past. A parallelogram by definition is a quadrilateral with both pairs of opposite sides parallel. So we have a set here and we have a set here. Some properties that we need to go over. We have that opposite sides are congruent. We have that opposite, angles are congruent. We have consecutive angles that are supplementary, so these two. And diagonals bisect each other. This doesn't necessarily mean that your diagonals are congruent, but that they split each other in half. Because our parallelograms' opposite sides are parallel, we've got some transversals that are created by our diagonals, so we're also going to have some alternate interior angles that are going to be congruent along the way. I'm not going to mark them all, but you guys get the idea. So a few problems here. If ABCD is a parallelogram and AD is 14, EC is 10, the measure of angle ABC is 65, the measure of DAC is 70, and the measure of angle BDC is 25. We're going to find each measure. So if I'm looking at side BC, I know that because this is a parallelogram, both pair opposite sides are congruent, so this will also be 14. Let's see, AC is the diagonal that is being bisected. So if EC is 10, so is AE, which means that AC has a value of 20. And now we're going to work with our angles. So if I'm looking at angle DAB, we first need to go through. We know that this entire angle here is 65, and our same side interior angles are going to be supplementary. So if I do 180 minus 65, that will give me 115 for a total here. That is DAB, 115 degrees, which also means that this one down here is 115. Let's see. Angle ABD, I've got a set of alternate interior angles here, so this one will also be 25 degrees. ACD, so I'm going to move this 70 here, and if this entire side has to be 115, then when I take away that 70, I end up with 45. And ADB, 65 minus 25 will give me 40. And then we can even keep going just to kind of double check our numbers here. If I do 180 minus 70 minus 40, that gets me 70 degrees for here. And if I do 180 minus 45 minus 25, that gets me 110. And just to check, this is a linear pair, so that works out. Remember that the inside of all of our triangles adds to 180, and the interior angles of a parallelogram, or of a quadrilateral in general, will add up to 360 degrees. So I didn't write this down. ADB is 40 degrees. All right. ABCD is a parallelogram. Find our measure of angle BAD. So here is BAD right here. I know that because this is a parallelogram, that these two angles here will add to give me 180 degrees. So if I add those two together, 10 and 5 gives me 15x, and if I do a negative 23 minus 7 more, that will give me a negative 30 is equal to 180 degrees. 15x is going to be equal to 210, and if I do 210 divided by 15, that gives me an x value of 14, and make sure that you plug it back in. So I'm going to do 10 times 14, which is 140, minus 23, which gives me a value of 117 degrees. Just a quick summary of parallelograms. Here are our properties. If parallelogram, then opposite sides are both parallel and congruent. If parallelogram, opposite angles are congruent. Our consecutive angles are supplementary, and our diagonals bisect each other. Now, if you want to go look at the long version of Unit 6, we have ways to prove parallelograms. So if both pairs opposite sides are parallel, then we have a parallelogram. If both pairs opposite sides are congruent, then we have a parallelogram. If both pairs opposite angles are congruent, we have a parallelogram. If one pair of sides is both congruent and parallel, then we have a parallelogram. And if diagonals bisect each other, then we have a parallelogram. The only difference between proving them and the properties is that you'll notice that in the properties we have the word supplementary. We cannot use supplementary angles to prove something to be a parallelogram, because if I take a look at a trapezoid of any type, if these are my bases and they are parallel, then these two will be supplementary, and so will those two. So we cannot use supplementary angles to prove things to be a parallelogram, but it is one of the properties of them.